In this episode, we are looking at a comparison that helps new defenders understand how security teams examine software for weaknesses before those weaknesses become incidents. Static analysis and dynamic analysis are both used to uncover vulnerabilities, but they do so from two very different vantage points, and that difference shapes what each technique can see clearly and what each one may miss. Static analysis studies software without running it, while dynamic analysis studies software while it is executing and responding to real activity. That sounds simple on the surface, yet it has major consequences for how analysts think about code, behavior, risk, validation, and confidence in findings. A useful way to frame the topic is to imagine one technique reviewing a building blueprint for design flaws before anyone moves in, while the other walks through the building during normal use to see what happens when doors open, elevators move, and people actually interact with the space. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. When security professionals talk about analysis techniques in this context, they are trying to answer a practical question rather than a purely academic one. They want to know where software might fail, how that failure could become a vulnerability, and what evidence is strong enough to justify action. Static analysis tries to answer those questions by inspecting code, compiled files, logic patterns, or configuration-related elements without executing the application itself. Dynamic analysis tries to answer similar questions by watching the application run and by observing how it behaves when it receives input, performs processing, accesses data, or interacts with users and other systems. Both techniques are trying to reduce uncertainty, but they reduce uncertainty in different ways. Static analysis leans toward structural understanding and early detection, while dynamic analysis leans toward behavioral evidence and real-world confirmation. And that difference is one of the most important foundations for a beginner to grasp. Static analysis is best understood as a method of examining what the software appears to be capable of doing before or without watching it perform those actions. An analyst may look at source code when it is available, or review compiled artifacts and structural clues when the original code is not directly accessible. The focus is on how the software is written, how data is handled, where trust boundaries may be weak, whether unsafe functions are present, whether validation appears insufficient, and whether sensitive operations are protected properly in the logic itself. Because the software does not need to be running, static analysis can be applied early in development, during code review, before release, or as part of broader quality and security assurance work. This makes it powerful for catching weaknesses long before users or attackers ever interact with the software. In a defensive mindset, that matters because fixing a flaw before deployment is usually less costly, less disruptive, and less risky than discovering the same flaw after the application has already become part of a business process. Dynamic analysis approaches the problem from the other side by paying attention to what the software actually does while it is running. Instead of reading logic and structure alone, the analyst observes the live behavior of the application when inputs are provided, sessions are established, requests are processed, and outputs are generated. This style of analysis can reveal whether an application crashes under unexpected conditions, exposes sensitive information through errors, mishandles sessions, trusts user input too much, or enforces permissions inconsistently once all the moving parts are active at the same time. Dynamic analysis is especially valuable because software does not always behave exactly as a simple reading of the code might suggest, particularly when configuration settings, libraries, runtime conditions, and integration points affect the final outcome. A program may look acceptable on paper and still behave badly under pressure, malformed input, or unusual sequences of events. For that reason, dynamic analysis gives defenders a view of software as a living system rather than only as a written design. One of the easiest ways to distinguish the two techniques is by thinking about timing and life cycle. Static analysis can happen very early, sometimes before an application is even fully assembled into a running environment, which means it supports prevention and early correction. Dynamic analysis usually requires a working application instance, a test environment, or a production-like setting where the software can be exercised and observed in motion. That means dynamic analysis often happens later in the life cycle, although strong security programs use it repeatedly rather than treating it as a one-time event near release. This difference in timing matters because the earlier a weakness is found, the easier it often is to address at the root cause level, but later stage testing may provide stronger evidence about what the software actually does in realistic conditions. Good analysts understand that timing is not just a scheduling detail. It changes whether you are examining possible flaws in design and implementation or measuring how those choices manifest under real execution conditions. A major strength of static analysis is breadth of structural visibility. By reading through code paths and logical branches, static analysis can identify issues in places that may be hard to reach during normal testing or unlikely to appear in a short execution window. It can flag dangerous coding patterns, missing validation checks, improper handling of untrusted data, insecure use of cryptographic functions, weak error handling logic, and permission checks that appear absent or inconsistent across the program. Another advantage is scale, because large volumes of code can be reviewed more consistently than a human could manage alone, especially when standard rules are applied across many projects. This helps organizations build repeatable review processes and gives developers earlier feedback while they still understand the code they wrote. For a beginner, the important point is that static analysis often sees the potential for a problem even if the exact failure has not yet been triggered in practice, which makes it especially useful for finding weaknesses before they become visible to users or attackers. Static analysis also has real limits, and understanding those limits keeps new analysts from overtrusting the results. Reading code or structural artifacts does not always tell you how the software behaves once it is deployed with real data, real configuration, real user actions, and real supporting services. A piece of code may look risky in isolation and yet be protected by safeguards elsewhere in the application, which can create false positives that consume time and create frustration. Static analysis may also struggle with issues that depend heavily on runtime sequencing, business workflow, environment-specific settings, or the interaction between components that are only fully visible when the application is alive and operating. If the original source code is incomplete, if third-party components are opaque, or if the application changes behavior based on deployment context, structural inspection alone may leave important questions unanswered. That is why experienced defenders treat static findings as valuable evidence, but not always as the final word on whether a weakness is truly exploitable in the way a report first suggests. Dynamic analysis has a different kind of strength because it focuses on observed behavior rather than inferred possibility. When a running application mishandles input, exposes internal errors, leaks data, accepts unauthorized actions, or behaves inconsistently across different user roles, dynamic analysis can often capture that in a direct and compelling way. This makes the results easier to explain to non-developers because the evidence is not only about a code pattern that might be risky. It is about the application actually behaving in a weak or unsafe manner under test conditions. Dynamic analysis is especially good at revealing runtime problems related to authentication, session handling, access control, data exposure, response handling, and interactions between components that only become meaningful once the application is fully operating. In other words, it helps analysts see software not as a set of lines on a page, but as a functioning service with users, states, dependencies, and consequences. That practical realism is one reason dynamic analysis plays such an important role in validating security concerns. Dynamic analysis has limits as well, and those limits are important because runtime testing can create a false sense of completeness if it is interpreted too casually. A running application can only be observed along the paths that are actually exercised during the test, which means hidden logic, rare conditions, deeply nested functions, or administrative workflows may remain untouched and therefore unexamined. If a weakness exists in code that the test never reaches, dynamic analysis may not reveal it at all, even though the flaw is still real. Results can also depend heavily on the quality of the environment, the realism of the test data, the range of roles being exercised, and the creativity of the analyst or testing process. A well-configured test may show clean results even though a different deployment setting would create dangerous behavior in production. This means dynamic analysis gives strong evidence about what was observed, but it does not automatically prove that everything important was observed, and that distinction matters greatly in vulnerability assessment. A simple example can make the comparison easier to understand. Imagine a web application with a form that accepts user input and then displays part of that input back to the user after processing it. Static analysis might examine the code and notice that the input is accepted, stored, and returned without sufficient validation or safe handling controls in one part of the application. Even before the form is run, the structure of the code may suggest that untrusted data is flowing into a sensitive output location in a risky way. Dynamic analysis, by contrast, would interact with the running form and observe whether specially crafted input actually changes the page response, produces unsafe output, triggers an error, or affects the application state in a way that confirms the concern. Both findings matter, but they answer slightly different questions. Static analysis says the logic appears to allow a dangerous condition, while dynamic analysis says the dangerous condition can be seen in action under the tested circumstances. Another helpful example involves access control rather than input handling. Suppose an application includes different roles for ordinary users, managers, and administrators, and some code paths are meant to restrict sensitive actions to higher privilege users only. Static analysis may identify that a permission check is missing or inconsistently applied in a function that handles account changes, export actions, or sensitive record access. That is valuable because the flaw may exist whether or not anyone has tried to exploit it yet. Dynamic analysis would then test the running application by signing in with different roles and attempting actions across those boundaries to see whether the restriction actually fails during execution. In that case, dynamic analysis can confirm whether the broken logic produces real unauthorized behavior in the live application flow. This comparison helps beginners understand that static analysis often detects the structural possibility of failure, while dynamic analysis tests whether that possibility becomes a practical weakness under real execution conditions and real user interaction. A common misconception is that one technique is modern and the other is old, or that one is only for developers while the other is only for security analysts. In reality, both techniques are still highly relevant, and both are useful to multiple parts of a mature security program. Static analysis is not merely a developer convenience, because the vulnerabilities it reveals can directly affect risk management, remediation planning, and analyst triage later on. Dynamic analysis is not simply an attack simulation, because much of its value comes from disciplined observation of runtime behavior rather than dramatic proof of exploitation. Another misconception is that dynamic analysis is always more trustworthy because it tests a live application, but live observation still covers only what was exercised during testing. Likewise, static analysis is not just theoretical busywork, because many severe vulnerabilities originate from code-level weaknesses that can and should be recognized before a running test ever begins. For someone preparing for CSA+ work, the most important professional lesson is that static and dynamic analysis are complementary techniques rather than rival camps. Static analysis can point analysts toward risky areas early, help development teams reduce weak patterns, and create a broader view of software risk before deployment. Dynamic analysis can then validate behavior, expose runtime weaknesses, and help security teams understand how those risks manifest in realistic conditions once the application is functioning as part of a larger environment. When findings from both approaches line up, confidence increases because the code structure and live behavior are telling a similar story. When the results do not line up, that difference becomes valuable too because it highlights where more investigation is needed, whether the issue involves compensating controls, incomplete test coverage, environmental differences, or simply a mistaken assumption in one of the analysis methods. Strong analysts become more effective when they learn to interpret that relationship instead of asking which single technique deserves total trust. There is also an important connection between these techniques and business reality. Security teams are not analyzing software for curiosity alone. They are trying to reduce the chance that a flaw in logic, processing, or enforcement becomes a real-world incident that affects customers, operations, compliance, safety, or reputation. Static analysis supports that mission by helping teams detect weaknesses earlier and fix them closer to the source, where changes are often cheaper and cleaner. Dynamic analysis supports the same mission by showing how the software behaves in a more realistic state, which helps teams prioritize what is actually dangerous in practice and what may require urgent remediation before release or continued operation. When an organization combines both views, it gains a much stronger ability to separate abstract possibility from observed behavior, and that leads to better decisions. In security analysis, that is a major advantage because good defense depends not only on finding flaws, but on understanding which flaws matter most in the environments where the software really lives. The big takeaway is that static analysis and dynamic analysis are two different ways of learning the truth about software risk, and both are necessary for a well-rounded understanding of vulnerabilities. Static analysis studies the structure of the software without running it, which makes it powerful for early detection, code-level insight, and broad review of risky logic. Dynamic analysis studies the software while it is running, which makes it powerful for observing behavior, validating concerns, and understanding how weaknesses appear in realistic execution conditions. Neither technique is complete on its own, because one can miss what the other reveals, and both can produce results that require human judgment and context. Once you understand the distinction clearly, you are better prepared to read findings, explain their significance, and think like a defender who wants both early warning and practical confirmation. That balanced mindset is exactly what helps a new analyst move from simply recognizing security terms to understanding how those terms guide real vulnerability work.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.